Start with the vertex. The vertex is 0, -5. So there's no shift left or right, so h is 0. But I have a shift down of 5, so it's -5. Okay, now the question is, what is a? Well, in our parent function, we saw that if we went 1 in the x direction, we went the square of that distance in the y direction. So 1, 1, okay. 2, 1, 2, 3, 4. 3, 1, 2, 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like we just have a is 1 because it's going up just as fast as the parent function was going up. So now that we have that information, we can say what the transformation is. It's a shift. -5's down 5. So that function is h of x, and I put an h just to be different, but I could have put g again if I wanted to. A is 1. You could write that, but for what, right? X, there's nothing happening to x before it actually gets squared. So I can just go ahead and write the square, and then I'm subtracting 5. Okay, now how do I know nothing's happening to x before the function is applied? Well, because h is 0. There's no horizontal translation. Okay. Now you're actually given the graph, so I don't actually have to put in the axis of symmetry unless I'm specifically asked to do so. Start with the vertex and ask ourselves, what is the coordinate of that vertex? Vertex. The coordinates of that vertex are 1, 2, 3, 1, 2, 3, and then -2. Okay. The slope on the right-hand side is 1, so a equals 1. Remember, for the vertex, the x-coordinate is h, so h is 3. And the y-coordinate is k. Okay, that's one way to think of it. Another way is simply to say to yourself, well, if I started at the origin, how would I get to this new vertex? Well, I'd have to go right 3, and then I'd have to go down 2. Okay, so that gives you the transformation. But it's very important that you specify the values of a, h, and k so that you can then write the function itself. Let's do j, just to be different. Equals. A is 1. Okay, so I'm not going to write that. Then we have absolute value of x. Okay, now there's a shift to the right. So that means there's something going on with x before the function is applied. So I start with x minus because the minus is in the general form. I look at h. H is positive, so I can just write the 3. Now the function is applied, the absolute value. And then k happens. Let's go to the next one. Well, we start with the vertex. Okay. The vertex here is -2, 3. Okay, so that's our h, and that's our k. So h is -2, k is 3. Quick check on a. Up 1, left 1, up 1, right 1, up 1, right 2, up 1, 2, 3, 4. Okay, it's looking like a is 1. Okay, so our transformation, if I was at the origin, how would I get to the vertex? I would shift. Okay, please don't forget the word shift. It's very important. Left 2 and up 3. So I can write the function. Let's pick another letter, just because we have a whole alphabet, right? A is 1. I can write that, but y? 1 is assumed in multiplication. We have x minus. Okay, now we had a shift left, so h is -2. So that negative sign on the 2 changes my minus to a plus. And we have 2. Then the function itself is applied, the squaring. And then afterwards, we have an effect on the output. We're just going to shift that up 3. That's the value of k. So that is our function. X plus 2 all squared, or the sum of x and 2 squared, and then plus 3. Here we have a function. The vertex here is 0, 0. So that means h is 0 and k is 0. Now, a, remember we talked about going, when I go right 1, I go up the square of the other. But notice here I'm not going up, I'm going down. If I want to go down, then we're really talking about a being negative. Negative what? Negative what? We're going down, right? 1 and the square of 1. 2 and the square of 2. 1, 2, 3, 4. 3 and the square of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like a is 1, but it's negative 1, right? Because we're going down. Okay, for quadratic functions that open down, a is going to be negative. In this case, it's negative 1. Okay, so our transformation is not a shift because the vertex didn't go anywhere. But we can say it's a reflection. Okay, reflection. We can either say across the x-axis, or we can say in the line y equals 0. Either is the same. Okay, so our function, I forget what letter we're on, L, I guess. Okay, a is negative 1, so now we have a negative sign. Okay, we could write the 1, but that's assumed in multiplication. Then we have our x. Okay, there's no h, so there's nothing happening to x before the function is applied, squaring. And then there's nothing happening after the function is applied. So it's just negative x squared. Now please keep in mind that this minus x squared means that you square the x first and then you apply the minus sign. If I wanted to apply the minus sign first, I'd have to put it in parentheses like that. Okay, so anytime you put it in your calculator and you don't put the parentheses, the calculator is going to do the same thing. It's going to square x first and then make it negative, which is fine if that's what you wanted to do. Here the vertex is 0, 0. But let's look at the slope. The slope is up 2, right 1. Up 2, right 1. Well, that makes a 2. Because instead of going up 1 and then right 1, we're going up 2 and right 1. So a is 2. Okay, so conceptually what we're saying then is instead of going up, every time I go right 1, instead of going up 1, I'm going up 2. So I'm going up faster than the parent function. So that's a stretch. In which direction? It's a vertical stretch. And then we have to say how much the stretch is, so we can throw in the words by a factor. It's not an English class, but let's put that a in there, of 2. Okay, so we take as a stretch. We're saying it's a stretch. That is, we're saying that it's in the vertical direction, it's going up at a different rate than it would have for the parent function. And then this factor of 2 means it's going up faster. Okay, so now our function is m of x equals 2, that's the value of a, x minus, well, there's no h. H is 0. And we don't really do x minus 0, do we? So then we can apply the function. And then there's nothing else going on outside, so we're done with that one. All right, so we've looked at the reflection in the x-axis, and we looked at a vertical stretch. Here we have a function whose vertex is at 2, 0. Okay. Well, this 2, remember, is h. This 0 is k. Okay, now the way I usually remember this is x and this is y, right? X comes before y in the alphabet. Well, guess what? So does h. H comes before k in the alphabet. So the first one is h, comes first in the alphabet. The second one is k, it comes after in the alphabet. A is the slope on the right-hand side. Remember in the parent function it was 1. And this one, it's actually 2. So A is 2. So a transformation is a vertical stretch. Comma, factor 2. And a shift right 2. Okay, dropping all kinds of letters. By, a, of, all gone, right? So what's our function? N of x equals 2 times the absolute value of x minus 2. Last one, vertex. -3, -2. We're opening down, so we know a is negative. But 1, 1, 2, 1, 2, 3, 4. Looks like a is just -1. H is 3, and k is -2. So our transformation is a reflection in the x-axis, and then a shift right 3 and down 2. Don't really like the letter O for my function, so I'm just skip to P. Negative, right? Now this is quadratic, so we're going to use a parentheses and suppose a line. That was for absolute value. X. Okay, now we got a shift to the right, so that we got something going on before the function is applied. So I do x minus. H is 3. It's positive, so I'll just put in x minus 3. The function is applied, so I square it. Then we need to move down 2. And that is our function. Okay, so that's today's lesson. You can see that, to summarize, that both of our functions, the absolute value and the quadratic functions, the parent functions had a vertex of 0, 0. We could use that fact when given a graph to immediately determine the transformation. Okay, so if the vertex is supposed to be at 0, 0 for the parent function and it's over 3, -2, we know we must have moved right 3 and down 2. That gives us our h and k immediately. So that vertex gives us our h and k. And then the value of a for the absolute value function was the slope on the right-hand side. If that slope was not 1, then whatever that slope was, that was a. Now we didn't do any absolute values that opened down, but you can imagine if this one had opened down instead of up, the value of a would have been -2 as opposed to +2. Okay, so if then they open down, the value of the a is going to be negative. Okay, if there are any questions, you can email me, by the easiest way to do that is just to log into Edline and click on the email me link. Send me any questions. There's a homework associated with this. It'll be posted to Edline along with this video. Okay, thank you. If everything is crystal clear, I'm posting the next video, transformation of functions 2, where we'll look at a few more statements and then we'll try to generalize to any function. Doesn't matter what that function is. Thank you and enjoy the rest of your day.